Okay, so I asked you to do some questions on this sheet, the second set. So we went over 1 to 4 already. That was the homework from yesterday. So now I had asked you to do starting with number 1. Now, some of you had to do 1 to 9, my level 1s. Others of you, I think I only did 1 to 5 because we hadn't gotten to the acceleration equation yet. Okay, so now remember steps in problem solving that I went over with you. Okay, read the problem, write down the givens, write down what you're looking for, check the units and convert any. Draw a sketch. Maybe you don't need to here because they're pretty simple, but when we get to tougher ones, I'll want you to. Write down the equation, simplify it and rearrange it for the unknown, substitute the numbers in with units. Okay, so that's how we're solving these. And I know you're thinking, man, I could solve them in my head. Right answer is worth 1 point. Procedure steps are worth all the others. One thing that I forgot to say that I'm going to add here, and I'll probably have to say it again a few more times for people who don't actually watch these, is positive and negative directions. Because we're dealing with vectors, we need to be careful of our directions. And so we tend to call, when there are 2 different directions in a question, we tend to call certain ways positive. So usually, oh, my hand keeps causing a glare there. Usually positive are up, to the right, north, and east. Okay, so those are the directions we usually consider positive, whereas negative would be down, to the left, south, and west. Now we really only have to worry about this if there's like an up and a down in the question, or something going east and then turns and goes west. If everything's going down or everything's going south, then just call that direction positive. But as soon as you have 2 different directions in the question that are opposite each other, then you need to call one way positive and one way negative. And these are the ones that we usually call positive, up, right, north, east. But you can call these ones positive, the opposite ones positive and negative. You'll still get the right answer. You just need to keep track of which way did you call positive. That'll become clearer as we get into more questions, I promise. All right, so number 1 says, determine the time. So I'm looking for delta t. Determine the time required for an object to travel a distance of 100 kilometers. So my delta d is 100 kilometers. At a speed of 75 kilometers per hour. That's my v-av, 75 kilometers per hour. So then I look at my equations and I say, oh, I have an equation that is v-av is equal to delta d over delta t, and I want to solve for delta t. So multiply both sides by delta t. So v-av delta t equals delta d, and now divide by the v-av. So delta t will equal delta d over v-av. And now fill your numbers in. 1,000 kilometers over 75 kilometers per hour. Is it really 1,000? No, it's 100, sorry. 100 kilometers over 75 kilometers per hour. Okay, that's like 4 over 3. So delta t is going to equal 1.3 repeating, and it tells you that you can have four significant digits, so 1.3 repeating. Now, just as a little aside, kilometers divided by kilometers per hour. Dividing by a fraction is the same as flipping and multiply. So multiplied by hours over kilometers, the kilometers will cancel. You will be left with hours, which is what you should be left with because you're finding time. Number 2, how fast would you need to go? How fast? V, and I think it's a v-av, but I'll know for sure when we read a little more. How fast would you need to go if you want to go 15 kilometers, delta t? 15 kilometers. In 15 minutes, delta t. 15 minutes. Okay, so now you got to take a look at the units. Up here we didn't have to worry about it, kilometers per hour and kilometers, but here kilometers in minutes. I would be tempted to say this is 1/4 of an hour and leave my kilometers in kilometers. So our equation is v-av equals delta d over delta t. I don't even have to rearrange this time. 15 kilometers divided by 1/4 of an hour, because that's what 15 minutes is. Dividing by a fraction is the same as flipping and multiplying, so it becomes 15 kilometers, and I'll leave my hours maybe down here. It's the quarter I'm going to multiply by, so 4/1. So my speed will be 60 kilometers per hour. Okay? Number 3. How far would you travel if you went 120 kilometers per hour? So 120 kilometers, 120 kilometers in 3,000. Oh, it is. How far have you traveled? It's not delta D. You're looking for how far would you travel. You should read the whole question. So how far would you travel if you were going 120 kilometers per hour at your speed in 3,600 seconds? That's your time. 3,600 seconds. Hopefully you recognize 3,600 seconds as 1 hour, because if you do, it makes your life much easier, because then you do VAV is equal to delta D over delta T, and you want to solve for delta D, so get rid of the delta T. It'll cancel here. So delta D equals VAV times delta T. So 120 kilometers per hour times 1 hour. Delta D is going to be equal to 120 kilometers. I didn't do sig figs up here. The second one could have 4, so it really should be 60.00 kilometers per hour. And this one can have 5, so it should also have 2 zeros on it. Number 4. An Olympic athlete runs a 100-meter sprint. So 100, I'll try to put all my zeros on and then I won't have to look back, in 9.830 seconds. What is his speed? So we're looking for his average speed. So VAV is equal to delta D over delta T. So 100 meters over 9.830 seconds should give you a VAV of 10.17 meters per second. And I'm allowed to have 4. Okay? Number 5 says a train leaves the station at 36 meters per second. That's my VAV. 36 meters per second. How long will it take it to travel? So how long, you're looking for time, will it take it to travel 1,620 meters? Okay, so again, VAV is equal to delta D over delta T. Rearranging for delta T, multiply both sides by it. So you have VAV times delta T, and then to get the delta T alone, divide by the VAV so that it cancels out. So we get delta T is equal to delta D over VAV. So 1,620 meters over 36 meters per second. And when you do that, I think you get 45 seconds. Delta T equals 45 seconds. Oh, and it probably is 4 sig figs, so 45 seconds, like that. Is it 4? Yeah. Okay, so there's the first 5. Next video, we'll do starting with number 6. Okay? Hopefully these made sense. If not, make notes of what you want to ask me when you see me in person. Thank you.